Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be considering transformations of unfamiliar functions. Now, what that really means is how you would transform a graph even if you had no idea what the equation of the graph was. First of all, we'll just remind ourselves what we've done in the last two lessons. We've been looking at two specific types of transformation. First of all, translations. And these come in two varieties. First of all, you can have a translation in the vertical direction, which would be something of this form, y equals f of x plus some constant a. And what that's saying is we're going to add on a to whatever the function is, which means add on a to the y values. So the graph will move upwards by a units. If a was 2, the graph would just move upwards by 2 units. If we adjust the x values, which is what we're doing here, y equals f of x plus a, and you'd be adding on a to wherever you have x in the function. Now the graph does move in the x direction, it moves horizontally, but the opposite direction from what you would expect. So when we add on a to the x values, the graph actually moves backwards by a units. It moves to the left by a units. Stretches are where we treat the graph like a piece of elastic. Again, there are two possibilities. You can have a stretch in the vertical direction, y equals a times by f of x, which will sketch the graph of f of x vertically with scale factor a. So if you had 2 times f of x, then the whole graph would stretch in the vertical direction with every point moving away from the x-axis, twice as far as the distance it was before. Again, if we adjust the x values, things happen the opposite way around from what you would expect. So if we multiply all of the x values in the function by some constant a, this actually stretches the graph with a scale factor horizontally of 1 over a. So if a was equal to 2 and you had f of 2x, we don't double all the x values on the function. When we draw the graph, we'd actually have to find a half of all of the x values. Now we can apply these rules for transformations to unfamiliar functions by considering how specific points on the graph are transformed. Let's have a go at doing this. So there's only one example in this lesson with 5 parts to it, and we're asked to sketch the graphs of the following transformations of f of x. And this red function here, this red graph, is the graph of f of x. Noting on each sketch the new coordinates of the points A, B, and C. So as you do each sketch, the general shape should be right, but take specific care with these points A, B, and C, and note the coordinates of where they arrive under each of the transformations. I'll let you have a go yourself first, pause the video, and come back to me again when you're ready. Okay, let's have a look at these. So the first thing we're asked to do is the transformation 2 times f of x. Well, that's a stretch in the y direction. If you have a stretch in the y direction, it means that every point is going to move away from the x-axis. The y values are all going to be doubled. So this point here, B, is going to move upwards. And instead of being y equals 8, it'll move to y equals 16. The x value won't change at all. This point here, it's going to move downwards. -4 will double to get -8. And this point here, where we cross at the origin, if you double that, it'll still be 0. So A isn't going to move, B will move up, C will move down, and you'll get something a little bit like that. The second question, f of 2x. Now here we're doubling the x values in the function. And what happens is the opposite from what you would expect. So when we double the x values, the graph is stretched in the x direction, but instead of doubling the x coordinates, we're going to have to halve the x coordinates. So a half of 2 will become 1. A half of 4 will become 2. Again, the origin isn't going to move at all. 0, 0 will stay as 0, 0, and these y coordinates will stay the same. And the graph will move something like that. The third question, a half f of x. It's like the first one. Again, it's a stretch in the y direction. And we'll just have to find a half of all the y values. The x values will stay the same. So again, a is going to stay where it is, but we'll find a half of 8, which will become 4, a half of -4, which will become -2. And that's what the new function will look like, a half f of x. Fourth question is a translation in the y direction. We're adding on 10 to the whole function. Now that means we're not going to distort the function like you do with a stretch. When you stretch a graph, you do distort it. With a translation, it's still exactly the same shape. It's just going to move up or down, left or right. And in this case, the whole graph is going to move upwards by 10 units. So this point here at B, the 8, the y value, that's going to go up to 18. -4, that'll go up by 10 to +6. And this time, the point A will move. So 0, 0 is going to move up to 0, 10. And the new function will look something like that. And then the last question, f of x plus 2. Again, we've got a translation. This time it's the x values we're changing. So the translation is in the x direction. And it's the opposite from what you would expect. So we're adding on 2 to x here. Now the effect of that on the graph is to take away 2 from all of the x values. So again, a is going to move, and it'll move backwards by 2 to -2. This point here will move backwards by 2, and that'll take it to the axis, to 0. And c will move back to the point 2, -4. And the new graph will look something like that. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 76 and have a go at exercise 4F. Thank you very much for listening, and cheerio.